In this video, we'll talk about how to graph linear equations in different forms. Just a reminder that we started off this unit talking about making a table for any equation. So as long as you can find x, y pairs that make the equation true, you only need to plot two of those to make a straight line. But let's talk about some of the shortcuts we found. So for instance, if you have an equation in slope-intercept form, meaning you have y alone on one side of the equation, you should be able to identify the y-intercept, meaning if I put 0 in for x in that equation, and I put 0 in for x, 0 times 2/3 is 0, subtract 4, my y-intercept will be at -4. So 1, 2, 3, 4. That is one solution to the equation. And then I can use the slope, right? The number in front of x, or the coefficient of x, is our slope, telling us a ratio of rise to run. In this case, my ratio is 2/3. So from this y-intercept, I can rise 2 and run 3, and I can make another point that will be on my line. And that gives me 2 points to connect and draw that linear equation. If I have an equation in standard form, like my second example, 2x plus y equals 4, I can find 2 points, and the easiest ones to find are the x and y intercepts. So we can make our little intercept table here. And if I put a 0 in for x, right, I get 2 times 0 plus y equals 4. And we see that the y needs to be 4 to make that equation true. So 0, 4, 1, 2, 3, 4 puts me up there. And then I can, start over, right? Get rid of this and say if I put 0 in for y, I have 2x plus 0 equals 4. And the x needed to make that equation true would be a 2. So 2, 0 would also be a solution to that equation. And then I can connect those 2 points. Maybe. There we go. It's not a very straight line, but you have the idea. So we have looked at slope-intercept form, standard form, and then there's a couple that look kind of funny to us still, but what happens if I get an equation where I only have an x or I only have a y? And those are just something you got to think about a little bit, that if we're saying the x-coordinate is 2, we can go to our x-axis, right? The x-coordinate would be 2 here, but we want to include all the coordinate pairs that also have a 2 as the x-coordinate, and that's going to give us a whole bunch more points, and we can show all of them with this vertical line. And so this gives us a vertical line with an undefined slope if we're trying to find all the points that have an x-coordinate at 2. Same holds true for y equals 2. Go to the y-axis where you know the y is 2 and include all the additional points where the y-coordinate would also be 2. And then this line would represent all of those solutions, giving us a horizontal line. All right, so those 4 examples gives you one in slope-intercept form, one in standard form, and then an example of a vertical and a horizontal line.